Hi, my name is David Owens, and this is kind of just a test setup to see if live streaming some Proteus development is worthwhile, if people like it, or yeah. So Proteus is kind of a language I've been talking about a little bit on my blog for a little while now. You may have seen it. I have a Patreon about it. But basically, it's just kind of taking a look at modern language development, and it's kind of a response to that. I don't really like how a lot of the languages are moving toward garbage collection or automatic reference counting with ARC, which is Swift. I feel like a language should allow the developer to utilize the machine to its fullest capabilities, but help the developers not make stupid mistakes. And so that's what Proteus is attempting to be. I think C was a really good language. I think it just kind of got left behind as developments didn't really get put back into the C language. So this is kind of just a reincarnation of what a modern C might look like. It's mostly to play around with and to see. I don't have any grand visions of this becoming as popular as C or anything like that, but just something fun, something to kind of take a look at and see if there are other options. Can we make languages that are as low level as C, but maybe as proficient as what Swift is looking like it's going to be, or languages like even like Python? Like, can we make the development in these low level languages just as fluent? And so this is kind of a take a look at that. I'm going to be doing all my development in Swift, at least initially, until that proves to be not a good choice, but I think it should just work just fine. I'm not going to probably be using Xcode very much. Xcode and I have been having a not good time together, so I've been relearning Vim, so I'm a little bit slower in it, and I'm missing a bunch of features like code sense, and code completion, and inline documentation that may be annoying. So I may switch to Xcode with the Xvim plugin, but yeah, we'll see. So yeah, basically I have a clean slate. In the Proteus directory, we just have this docs, and the docs are really just a stub of this, which is going to be where all the compiler documentation and standard library documentation goes. It's just hosted on my blog. You can see it, onsd.io. Proteus will give you to the docs. But again, there's nothing there other than kind of a high-level statement about what I would like Proteus to turn into. So with that, let's go ahead and get started. So, alright, so I have that docs folder. So what I'm going to do is go ahead and create probably like a source folder and a bin folder to put our stuff in. I don't really have any plugins really in my Vim setup, so I think for now I'm just going to use the built-in make support. So I'm just going to create a make file. That's just going to turn around and call the Swift compiler. So let's go ahead and get started with that. Edit make file. All right. So it's been a while since I've done make files. Let's see. We want to create a variables for the bin and source folders. So binder and source dir. Then we need like targets, kind of targets. Yeah, I never really got into makefiles too much. I think the reverse dependency lookup thing, but it's okay. We'll just call it .c, and what it's going to do, it's going to make our directory if it doesn't exist. And then we're going to turn around and call the Swift compiler. for all the Swift code inside of source. So with Swift 2.0, you don't have to do the whole specify the main Swift file and then specify the rest of your Swift files, so that was pretty nice. One thing here, I want to use xrun, and what this does is it's going to allow me to pick the Swift compiler that you have set as your default. And so, like, I can come over here and run xcode select -p, and this tells me which Xcode version I'm running. So Swift is coming out with betas every couple weeks, and so typically Swift developers will have their RTM version of Xcode that they can use to build apps and ship them to the App Store, publish them to the App Store. And then they'll have the latest beta drops so they can test out SDK changes, additions that are coming up in future releases, but also so that they can make use of some of the newer features of Swift if their app isn't going to ship for a little while. So xrun will allow us to pick the one that's the default based on the path. And so right now I'm just going to write this for Mac OS X. I think that's right. And then Swift C. And then we just want to write all of the source dirs, all those files. And then we're going to output this to the binder and Proteus. Okay. And then we're going to create a phony target clean, and then clean, which will remove dir. Actually, it'll just remove everything from the binder. It won't actually delete the dir. Okay. So now we'll run make. Right? Yep, good. So just down here, it's failing, but we don't have any Swift files yet. So let's come over here and create our first one. And we'll test out our build and make sure it's all working. Alright, so we're going to import Foundation to make sure that our SDK is coming in for the platform. And then we're just going to print out a message. Save it and run it. Sweet. No errors, everything looks good. Let's look under bin. Perfect. Welcome to Proteus development. So there we go. We have our basic build system all set up and ready to go for our Swift files. So what I'm going to do is go ahead and create a test folder. And then let's go ahead and create just a real basic prop file, Proteus file. So it's going to look like this, import a standard lib, and then it's going to have the same thing, print, welcome to Proteus. Right. All right, so this is the basic structure of the language. It's going to have basically a lot of Swift-like syntax, and we want to make use of a limited set of type inference. I'm only going to probably do type inference at the declaration site, because I think that's the only place where it really makes sense without actually trying to build something really complicated. And so, yeah, so what we're going to do is we're going to start off building a scanner that can walk through the file, right? And then a lexer that can get the tokens from the file, I think is what we want to do. And I guess I should preface this. I am no means a language compiler guru. I haven't written a parser for many years. I've written a bunch of tokenizers and stuff like that for very simple stuff, and mostly for metadata programming around Objective-C or C-type, so that we can get rid of some of the monotony that was required in those languages, but nothing as advanced as this. But we'll go ahead and get started, and we'll see how we go, and hopefully if you're watching along, you don't get led too astray. Alright, so why am I in insert mode? Okay. So yeah, so with that, we're gonna go ahead and I think I'll just go ahead and do it in this same file for now. Alright, so I think what I want is I want a class and I want a scanner. And the reason I want a scanner is I want to be able to track line and column offset. And so I need to know when I hit new lines. And another thing about Swift strings is they're O1 to traverse, but to go and get substrings and stuff like that, I think a lot of times you're going to end up with like ON performance. Or you need to keep track of the string indexes and then do comparisons between or ranges between the actual index types of strings to alleviate yourself from getting the ON performance. But then we want to convert that back to column and line information that the user is going to be seeing, and those are integer values. And so yeah, we're just going to do a scanner class to kind of keep track of all of that for us. This is not a struct because it is not a value type. There's no real meaning of equivalence between multiple scanner instances, so it just doesn't really make sense to do a struct. Alright, so some of the things that you need in a scanner are, we're going to need a function for peaking, and maybe it's going to give us a string, and maybe it's nullable. I don't know yet. We'll just do that for now. We definitely need a function for the next character in the stream. Okay, and we're going to need that stream, the content. So content. So that means we're going to need an initializer. This is one really annoying thing. Oops. Hello, Vim. Nice to meet you. Okay, this is one of the annoying things in Swift. We have to add all this boilerplate for initializers on class because those are not public by default. They're private. I think they're private. I guess it doesn't really matter since everything's in the same file, but yeah, whatever. Okay, so what we're going to do is we're actually going to go ahead and just kind of build this as we go with some really basic running of a specific file, just so we can kind of spit out the content as we go. So we're going to delete that line. Alright, so we're going to let the scanner, so this is another kind of weird thing. I don't know how familiar everybody is with Swift, but let is constants, but it's basically the exact same thing as by val and by reference constants in C languages. The let basically just says, hey, that the value itself that this holds cannot be mutated. But for a class, that value is essentially the pointer. So you can't change the instance that the scanner is pointing to, but you can change all of the members of a scanner. had this been a struct, then the struct is a value type, and then you can't change any of the members, any of the value members of the struct. So yeah. All right, so we got our scanner. We're going to need to load this content. This content is going to be a string contents of file, some path. In the encoding, we're just going to treat it as UTF-8 encoding. All right, and then the path, we're just going to cheat for now. We know it's going to be in the test directory, and it's called, what is it called? Basic.prot, right? Yeah. And so what we're going to do is we're going to call scanner.next. Actually, yeah, scanner.next is going to give us the next character, right? And so really what I want to do is I just want to just do this. So while scanner.next does not equal nil, right? What I want to do is, whoa. All right, still learning Vim. Getting my keys all kind of silly. I'm just going to go ahead and print the value that the scanner has at that point. So, all right, so these are both going to be nillable. I know that the peak has something because the next isn't nil, and so I'm just going to do that. And then terminator is going to be that. So the print function in Swift is really annoying. I wish they just had the print and print line still. Like, I don't need all this crap. I just want to print. I just want to print that single character out. And I want to go through, and all I'm going to do is output the contents of that file. And we're going to make sure our scanner can go through and walk through the file. That's basically all we're doing. Okay, so next, what is next going to do? All right, so like I said, I want the line content. It's going to be an integer and a column. Yeah, we're going to do something with that. But, we know we want to track that. And then, oops, I also need the current index that we're at. And that's string.index. Do I need that? No, I don't need that. What I do need though is the current character. Right? Okay. So our current string value. Whoa. Okay. So we have the current value. Okay, and so peak, all peak is going to do is going to return that current. All right. And what next is going to do is, oh, maybe I do want to keep the index so that I can do this. Yeah, right, because I want to do content index. Well, actually I want index equal index dot successor. And then if index does not equal index, oops, content dot index. Actually, what do I just want to return index equals and index, right? Nil, otherwise it's content index. All right, so then we're going to need is var index and string.index. Alright, so if I say it actually always starts there, so then we're going to let the value equal the end of that. We're going to go like that, and we're going to go like that. Then we'll return value. Alright. Let's build it and see what happens. Alright, so expressions have mismatch type, nil, literal, convertible, and character. Oh, okay, so that's a character. Alright, that's fine. So okay. Really? It's an optional character. That seems like a really stupid error. NS UTF-8 encoding. Alright, so okay, maybe alright, maybe if we did this, alright, it fixes that. Foundation is imported. NS UTF encoding is not found. Unresolved identifier, NS UTF-8 encoding. That looks pretty good to me. So let's go ahead and go to the Apple Docs and see what library it's in. Oh. Okay. Alright, yep. And then we need to convert the... Alright. Right. Need to get my build to autosave the file. Alright. Let's go ahead and clear that. See what happens. Ooh, exception. The file basic prot could not be opened because there is no such file. Ah, right. The working directory is actually what dictates the path. Maybe I should just pass in .c. Yeah, let's just go and do that. Alright, so how do I get the command line arguments for Swift? Deleting quotes. Okay. So, I forget what the environment variable is for Swift. Swift command line arguments. I think it's like NS arguments. Oh, it's process starter arguments? Okay. Okay. Seem to work. Okay. Process couldn't be opened. Okay. What? Ah. There we go. Okay. Obviously, we will want some like real air handling and things like that, but that's okay for now. We're just doing some tests. All right. Unexpectedly found nil and unwrapped an optional value. That's less than stellar. Yep. That means, yeah. Next needs to actually set the current. That would be, pretty helpful. So the current equals the value. All right. Boom. Okay. All right. And so now what we need to do is we need to okay, so evidently, okay. So we can't do the end index here. Okay. Guard let value. No, it's not even guard. It's just if index equals content dot end index. Return no. Right. Otherwise, value equals content slash index. The current value is the value. How about we just do this? Increment the indexer and then return the current. Love it. Let's clear that, rerun it. All right, there we go. All right, so our scanner is working. Excellent. Now what we want to do is we want to start writing our lexer. And again, I am actually just going to write that in this same file. And we can start moving it out. All right, let's start moving it out, I guess. All right, let's just create a file called parser. Okay, and then we'll put all of this stuff in. Okay. See if this still works. Oh, crap. Boom. Okay. So now inside our parser file, we're going to go and create a class called lexer. Again, this is a class because the value type for this makes no sense to me whatsoever. It's going to need the same things. It's going to need a next and a peak. Alright, and yes, I know we haven't done anything with the line and the column number up there. We'll get to that later. Next. Okay, now a lexer actually needs to return meaningful data. Structured. So we're going to need to create some sort of token type. Okay. All right. Now, our tokens. Our tokens. So we can either make them enums, right? Because there's going to be different types of tokens. So if we look back, if we look at the tests basic.profile, we have import, which is a token, standard lib, which is a token, print, which is a token. We have, I mean, technically this space is a token as well. The new line is also a token. We just tend to ignore those. The parenthesis is a token. The quote is a token with the entire content being the value of the string. And then we have that end parenthesis token. So there's a finite amount of tokens. Like standard lib would be considered like an identifier or a name. Import would be a keyword. And print would also be another identifier. So enums, yeah, let's just go down the enum path and see what we get. Enum token, right? All right, so we have case identifier. And we're going to use the associated values. So we're going to have a string. And so this is where we're going to really actually want to add that line and column, or at least offset in there, so that we know where that token came from. Ooh, it's getting late. We need a keyword. We need a open paren. We need a close paren. And we need a string literal. Okay. I think that will be enough tokens to parse this file. Okay, so what we're going to do is we're going to hand code a recursive descent parser. And so I only kind of know basically how to describe this. Essentially, we're going to go through here and just continue kind kind of recursively going down into the different things. So we're going to see, hey, this is an I, so this is likely to be this can only be a certain set of our tokens. And in this case, it can only be an identifier or a keyword. And so then we're going to go and recurse into another function to go parse that keyword or parse that identifier and pull it out. And then it'll pop up a level and continue all along our scanning route. All right, so the Lexer is going to need a current token. We're going to assign that to nil. It's also going to need probably the scanner to work with. Okay, which means we are now going to need an initializer. The boilerplate. Okay. Okay, so peak is easy to implement, right? We just return current. Next is pretty easy to implement because it's basically the same structure as the one above. Okay, so let's just do this the easy way. No. There we go. All right. What do I want? Where's my cursor? Okay. Yeah. I'm just looking at the time. It's 2 a.m. here. Okay, so I think I'm gonna actually stop there for tonight, and then next time we'll pick up going through and building this Lexer out. It shouldn't actually take very long to go do that, and then we'll get that information started to be printed out, and then we'll take a look at probably turning this really basic thing into an AST, and then I'm just gonna, to start with, write a rewriter. So we'll turn that AST into C code, and then we'll get that C code compiling. So then we can start actually writing some basic programs inside of Proteus pretty quickly. And then it'll really just be iterating on some new features inside the Lexer, if the scanner needs anything else, just to support the new kind of constructs we want. So we'll probably get print working. We'll have to special case some of that stuff to get that to output to like printf and C. But that's okay. And like the import standard lib, we'll hand wave a lot of that implementation detail to begin with, and then we will move on and get like functions and variable declarations in there. And with those two things, we should be able to do actually a lot with the language. And then we'll take a look at how we're going to do like memory management type constructs. Okay, cool. All right, thanks, and until next time.